So we're going to talk about greenhouse gases now. So carbon dioxide is one of the big greenhouse gases. And I showed you before that with the Vostok ice core data, carbon dioxide and global temperatures match up pretty well. More recently, we've been getting more precise carbon dioxide data by actually measuring carbon dioxide in the air. So the earliest data came from an observatory on Mauna Loa volcano, Hawaii in 1957 by Charles David Keeling, and it's called the Keeling curve. The initial measurements showed carbon dioxide increasing at 0.5% per year since the data collection began. So in 1958, the levels were 315 parts per million, or ppm, and now they exceed 410 ppm. If this trend continues, we could double atmospheric carbon dioxide within this century. So that's a lot. This shows that data. There are two main patterns here that you should recognize pretty easily. And so the red is the monthly mean carbon dioxide. The black line is just they've smoothed that by year. So the first thing you should notice is that carbon dioxide has been going up every year, pretty much. And so we've seen a steady increase in the amount of carbon dioxide in the atmosphere every year. The second thing you should notice is this up-down pattern. And every year, carbon dioxide goes up in the winter through our spring, winter, spring of the Northern Hemisphere. And in the summer, fall, it goes down again. And so it's this seasonal pattern of up, down, up, down. And I'd like you to take a second and think about why you think that seasonal pattern might occur. And if you need to think for a little bit longer, you can pause the video. So what affects how much carbon dioxide is in the atmosphere? What's a big thing that's seasonal that affects carbon dioxide? The answer is trees. Trees take in carbon dioxide to make all their leaves. And so in the spring at leaf out, trees need tons and tons of carbon dioxide to build new leaves with. And then in the fall, they drop their leaves. They stop doing photosynthesis for the whole winter. Obviously not all trees. We're talking about deciduous trees here, broadleaf trees. And the reason that this results in a global change is that most of the land area on the planet of the Earth is in the Northern Hemisphere. So most of the deciduous trees are in the Northern Hemisphere, in North America, Europe, and Asia. And in the spring, they start pulling carbon dioxide out of the air. And through the summer, the carbon dioxide concentrations in the atmosphere go down. And then in the fall, they let go of their leaves and stop doing photosynthesis. So they stop taking carbon dioxide out of the air, and the carbon dioxide concentration starts to go up again until the next spring, when they start to put their leaves back on and they start pulling carbon dioxide out of the air again. So that's what causes this up-down pattern every year. What causes this upward trajectory is our burning of fossil fuels and our land use changes that destroy forests and change land use. So this puts the two together. So we have from 400,000 years ago to about 1950, this data uses the Vostok ice curve. And then this part of the curve that shoots up today is the Mauna Loa data. And so you can see we've gone way past the highest historical carbon dioxide level. And this graph doesn't even go up to the present because it's only going a little past 380. We're higher up at this point. And then I want to pull up, you can look up what the carbon dioxide concentration for today is. And so you can see 415.36 parts per million. That's from 2 days ago, January 2nd. And these are all of the measurements for the last week. The gray dots are the hourly average and the black dots are the daily average. And so we can go back and see other records as well. So 415 is very high. And you can see they can put it into context for the longer term record. And you can see here, this one includes up to more recently. This goes through July of 2020. You can see that the numbers have still been increasing even into the summer of 2020. Now there's a possibility that it was going to be a little bit different, but 415 tells us that we're still in dangerous territories here. Okay, so that shows the record. So of course carbon dioxide isn't the only greenhouse gas. Greenhouse effect obviously is important. It keeps the Earth 33 degrees Celsius or 60 degrees Fahrenheit warmer than it would be otherwise. So without the greenhouse effect, the Earth would be really, really cold. And so 60 degrees cooler without any greenhouse gases would be dramatically different than today. So we want some greenhouse effect, but we're getting too many greenhouse gases at this point is making our climate warmer. So they look at the different greenhouse gases, and the main ones are carbon dioxide, methane, nitrous oxide, and hydrochlorofluorocarbons. Let's see. Oh, that's not what I wanted. So carbon dioxide and methane are the most important ones. But the other ones are all more powerful than carbon dioxide. And what that means is that each molecule of the other ones that aren't carbon dioxide trap more heat than one molecule of carbon dioxide does. Carbon dioxide is also smaller. But you can see this 23 here means that one molecule of methane can trap the equivalent of 23 molecules of carbon dioxide, and so on. But there's a lot more carbon dioxide, which is why we talk about it the most. This shows their lifespan and the sources of these different greenhouse gases and their proportional contribution to global warming. So you can see here that carbon dioxide makes up 60% of the contribution to global warming. And it stays in the atmosphere for 500 to 200 years. So that's a pretty long time. So we're mostly talking about carbon dioxide because it has the largest contribution to global warming and it can stay in the atmosphere for a very long time. Methane is the other important one because it makes up 20% of the contribution to global warming. And methane is basically the same as natural gas. So if we have leaks from drilling natural gas, that is a direct contribution of greenhouse gases to the atmosphere. They're also, it's also produced by ruminants, so like cows and sheep, and by growing rice in wet paddies. There's also the generation of methane, and you can also have its release by coal mining and by burning things. It has a much shorter life in the atmosphere, only 12 years, but again, it does have a higher warming per molecule, so it does make a large contribution still to global warming. Halocarbons make up 14% of global warming, and nitrous oxide makes up 6%. This shows the concentrations of these three major greenhouse gases through time. And you can see that carbon dioxide is not alone. It's not the only one increasing rapidly. All three of them are increasing exponentially. So they increase a lot every single year. And to deal with this, we need to stop producing so many greenhouse gases, basically, and get to a lower level, ideally.